Hello everyone, this is Group 16 featuring me, Virgel Gubat, Abigail Jan Guillermo, Stephen Mendoza, and Kyle Joseph Mendoza. And here we are presenting Chapter 17 entitled Electrochemical Reactions. And I hope that you will enjoy the video.
Electrochemical reactions. Electrochemical reactions are chemical reactions that produces a voltage, thus creating an electric current. The branch of chemistry that studies electrochemical reactions is electrochemistry. Electrochemistry is a branch of chemistry that studies about the interconversion of chemical and electrical energy. Galvanic cell. A galvanic cell, also referred to as a voltaic cell, is an electrochemical cell that uses chemical reactions to generate electricity. In this cell, chemical energy is converted to electrical energy. In the illustration of a battery, you can see two electrodes, as well as the movement of the electrodes that causes the light bulb to light up. A half cell is a structure composed of a conductive electrode surrounded by a conductive electrolyte. In the illustration, the zinc and copper metal plates are the electrodes and the zinc sulfate and copper sulfate are the electrolytes. This illustration is an example of a zinc-copper cell. This is made up of a zinc half cell, which is in the right side, and a copper half cell on the left. The picture above shows two half reactions. A half reaction is a part of an overall reaction that represents either an oxidation or a reduction. The half reduction that takes place in the zinc plate is called the oxidation half reaction, while the half reaction that takes place in the copper plate is called the reduction half reaction. What happens in the zinc-copper cell? At the zinc electrode, every time it loses two electrons, it also causes the zinc and solid form atoms of the electrode who donated the electrons to become zinc ions with a positive 2 charge, which are dissolved in the zinc sulfate solution, causing the zinc electrode to lose mass and the volume of the solution to increase.
Half reaction in the zinc half cell is shown in the presentation.
On the other side of the cell, as it continuously receives electrons, the copper electrode at solid form will be more electronegative than the copper sulfate solution. This is the half reaction for the copper half cell. The overall reaction is like this. The zinc atom reacts with copper ions and 2 electrons, forming zinc ions, copper atoms, and 2 electrons. This is the standard notation. The ones written before the single line represents the phase before the process happened, while the ones written after the single line represents the results after the process has been done. The single line represents the phase change, while the double line represents the physical boundary or the salt bridge. The components of a galvanic cell. First is an electrode. It is an electrical conductor used to make contact with the metallic part of a circuit. This is responsible for the electron exchange between cells. Anode is the electrode where oxidation takes place, and cathode is the electrode where reduction takes place. Second is electrolytes. It is a substance that contains free ions and which therefore behaves as the electrical conductor. Lastly, the salt bridge. It is used to neutralize the solution so that the flow of electrons in the outer circuit continues. Uses and applications of a galvanic cell. First, batteries. The principles of galvanic cells are used in making electrical batteries. One of the electrochemical devices used in making a battery is galvanic cell. Batteries are used for household appliances, digital cameras, hearing aids, and military applications. Second, electroplating. The galvanic cell can also be used for electroplating. It is a process of coating an electrically conductive object with a metal using electric current. Electroplating can also be used to give certain properties like wear resistance or corrosion protection to a metal. Other uses are for aesthetic purposes like reduction of jewelry.
Electrolytic cell. An electrolytic cell is a type of cell that uses electricity to drive a non-spontaneous reaction which is opposite the galvanic cell. What is electrolysis? Electrolysis is a method of separating bonded elements and compounds by passing electric currents through them. Electrolysis of copper sulfate. On the demonstration, the initial color of the solution didn't change, but some of the copper have been deposited on the negative copper cathode and lost on the positive copper anode. Electrolysis of water. Water can also go under electrolysis to form hydrogen and oxygen gas. Comparing galvanic and electrolytic cells. This is a table representing the difference between galvanic and electrolytic cells.
Chapter 17.4 The Standard Electrode Potential. What is standard electrode potential? In electrochemistry, standard electrode potential is the measure of the potential or ability of every metallic electrodes to give off or lose electrons. The measurement is also dependent on the standard state or form where its ions are at definite concentration of 1 mole decimeter at a constant pressure of 1 atm and temperature of 25 degrees Celsius. Different reactivities of metals. Every metals in the periodic table form different kinds of chemical reactions. Since metals always tends to lose its valence electrons, then they always form positive ions or cations. Observe the reactivity of metals below. Equilibrium reactions in half cells. Observe the electrochemical cell. It contains one electrode in each half cell, which are zinc and copper. The reaction they made are the following. As you observe, zinc gets easily oxidized as it lost 2 electrons, while copper on the other hand gets easily reduced as it gained electrons. So the transfer of electrons from zinc to copper half cell will continue until both systems reach the dynamic equilibrium where the potential buildup across both electrodes equals to 0, which indicates that there are no more electron movements from both cells. Measuring electrode potential. Combining 2 half cells can build a full electrochemical cell, galvanic or voltaic cell, which could cause a voltage buildup or potential difference between electrodes, which is the one responsible for an electron exchange across electrodes. The principle of cell reactions. Number 1. In a single full cell, there should always be potential difference between 2 electrodes composed of different metal or element. Number 2. The reaction in an electrochemical cell should continue spontaneously until reaching a dynamic equilibrium. Standard hydrogen electrode. Hydrogen electrode is a redox electrode which acts as the basis of the electrode potential of other electrodes. It has an estimated electrode potential of 4.44 to 0.02 volts at 25 degrees, but equates to 0 at the standard condition at any temperature. This hydrogen electrode just bridges the ability of scientists to measure the electrode potential of other electrodes. So a hydrogen electrode consists of platinum electrode is in a solution of hydrogen sulfate which contains H+ ions at a concentration of 1 mole decimeter. The reaction is shown below. Standard electrode potential. It is important to understand the difference between the relativistic and absolute measurement. They are not similar to each other, but just approximately equal to each other. So let's proceed to the conventional and voltage sign. During the experimentations, it is also important to know the positioning of voltage signs relative to the electrodes. The positive sign of voltmeter must be connected to the lower electronegativity electrode, while the negative must be connected to the higher electronegativity electrode. Combining half cells. Combining 2 half cells, zinc half cell and copper half cell, can form whole electrochemical cell which would obtain the following equilibria below. As stated earlier, in a cell, zinc tends to act as an oxidizing agent while copper is the reduction agent in every half cell reactions. A voltmeter attached will be measuring the potential difference across cells and will also determine the more electronegative one. So the potential difference measured by voltmeter is also known as electromotive force or EMF. So what is electromotive force? In electrical engineering, EMF is defined as a driving force for an electrical current driven from positive to the negative terminal. It also defines the voltage or potential difference across 2 points. In a cell, EMF is defined as the ability of every element to give off or lose electrons, and also the potential difference across 2 half cells, which is directly proportional to the strength of reaction. So the stronger the electromotive force means the stronger the reaction will be. Standard EMF of electrochemical cell. Standard EMF is defined as the EMF in an electrochemical cell at standardized condition. The symbol represents the standardized condition. Lastly, it is also important to understand the relationship between equilibrium and potential difference, where the potential difference defines the extent of the spontaneous reaction and whether it had already reached equilibrium or not. The increase of product's concentration and the decrease in the concentration of reactants states that the reaction is already reaching equilibrium. Uses of standard electrode potential. Standard electrode potential has various uses which includes the following. Number 1 is calculating the EMF of a cell. The following formulas in the illustration are used to calculate the EMF of the cell. Number 2 is predicting whether a reaction will take place spontaneously. The direction of equilibrium determined by the electrode potential will determine whether the reaction will take place spontaneously or not.
Redox reaction, or also known as oxidation-reduction reaction, is any chemical reaction in which the oxidation number of a molecule, atom, or ion change by gaining or losing electron. Now, how does this relate to the previous topics? Well, Abigail introduced the equation of a half reaction which can be used to balance redox reactions. Now, there are steps that we can do to easily navigate our solutions for balancing redox. You can pause the video to see the examples. Electrochemistry is very vital in a wide range of important technological applications. To name a few, we have electroplating, production of chlorine, and extraction of aluminum. Electroplating is a process of using electrical current to coat an electrically conductive object with a thin layer of metal. Electroplating allows manufacturers to use an expensive metal such as steel or zinc for the majority of the product and then apply different metals on the outside to account for appearance, protection, and other properties desired for the product. Electrolysis can also be used to produce chlorine gas from brine or seawater. This is sometimes referred to as a chlor-alkali process. Chlorine is a very important chemical because it is used as a bleaching agent, a disinfectant, in solvents, pharmaceuticals, dyes, and even plastics such as polyvinyl chloride. Electrochemistry also applies for the extraction of aluminum. Aluminum metal is a commonly used metal in the industry where its properties of being both light and strong can be utilized. It is also used in the manufacture of products such as airplanes and motor cars.